Our group is presenting innovative technology of thermovision tomography. This technology can be used in prospecting of solid mineral deposits and onshore and offshore oil and gas deposits. It can also be used for diagnostic of oil and gas pipelines and in construction of metro, tunnels and high-rise buildings. Here is the geography of our projects. We are now in more than 15 countries, including Russia and Kazakhstan. As a source in the basic data, we use infrared images with the wavelength range from 8 up to 14 microns. We also use visible range images and map of the terrain and bathymetry if necessary. After some calculations, as a result, we get a 3D model of thermal field of the area. Red color shows us high temperature, blue color is for low temperature, and transitional zones are shown by green color. Then scientific team makes processing with the use of developed algorithms. And as a result, we get vertical profile of block and fold structure, which shows us rock density. Red color is a dense rock, green color is transitional zones, and the compaction zones are shown by blue color. Here we can see the different types of TVT images. Image A is a vertical monochrome profile in which black color shows us fold and white color is a dense rock. And image B shows us the same fold, which is shown by the black line, but in horizontal section, 3 km depth. Well-known examples of morphology, but in TVT interpretation. Here are the pictures of graben and horst structures. Red color is a dense rock, the horst. Blue color is a decompaction zone, the graben. We also use 2.5D maps to see the geometry of the area. On this picture we see thermal field graph. It shows abnormalities typical for dense rock, red color, decompaction zones, blue color, and transitional zones, green color. Most favorable places for hydrocarbon accumulation. Below this picture we see monochrome block and fold TVT image with overlaying of electral logging. There is a strong correlation between green transitional zones of thermal field graph and electro logging data. We also use model of formation of local heat sources. This image helps to detect areas with perfect conditions for hydrocarbon formation. Simply saying, we can see the places where oil is cooked. And this is the stress of vegetation graph, also built with the use of TVT technology. It shows us its correlation with outcomes of hydrocarbons. We can see that vegetation is stressed in the spots where oil and gas come out. It's one more additional sign of oil and gas deposits. This slide provides information on TVT technology advantages. First of all, it has very short execution period in comparison with any traditional method. For 1000 square kilometers, roughly we need from 3 up to 6 months. It depends on task and complexity. Secondly, it's more economical versus existing traditional methods. We use satellites, so physical presence is not required. TVT can be used for any geological environment and any rock type. This technology is regardless to relief, terrain and bathymetry conditions, including complex fault structures. It has very high spatial resolution. Our technology has no problem identifying oil reserves even due to interference from gas clouds, which are usually a huge problem for hydrocarbon explorations. With the use of TVT technology, we can build vertical and horizontal profiles of block and fold structures at any given depth and in any direction. The maximum depth is up to 100 km. And last but not least, it has zero environmental impact. TVT technology has three levels of study: regional level of study, zonal level of study, and local level of study as well. Every level has its own purposes and tasks. Some examples of TVT usage. We have different examples in different countries, and here we can find TVT explorations on green fields, brown fields, assessments of dry wells, scientific works, and some more. But let us go through, step by step. Now we are going to tell you about TVT direct applications, and here is the first field of TVT application. It's green field. When nothing was done and no surveys and explorations were made, TVT technology can stand by itself, and all we need to start our work is just GPS coordinates of licensed block. We have 24/7 access to satellites data, and we start working immediately. As we were saying before, there is no need in physical presence, which means that logistic issues, safety issues, and weather barriers are no longer important. According to a task, we choose TVT level of study. It can be regional level of study for quick surveys, zonal level of study for preparation of an area for prospect drilling, and local level of study, when we get detailed information about the block and the target drilling. In every level of study, TVT technology is efficiently regardless to relief or terrain conditions. So as a final result, as per a local level of study, we get target drilling information. We provide client with information about exact spots where to drill, about its coordinates on a map, and its exact depths on a vertical profile. Let's take a look at this example. TVT exploration, local level of study, Volga-Ural province, Russia. It is a green field, and all we had is this map of licensed block. And then we got terrain map, and with the use of TVT we built different vertical profiles and horizontal sections. Here is one of those sections. Horizontal section of local thermal field. We chose as proper conditions for hydrocarbon accumulation. And then we build the map of perspective areas. Green color shows perspective zones. Violet color shows not perspective zones, and uncertain prospects are shown by blue color. And the company started drilling according to our recommendations. And here is the table with the result of TVT analysis. For the one structure, Surilovskaya structure, the seismic survey was done, and it showed perspective zone, although the TVT analysis showed not perspective zone. And as a result of drilling, no collector. All the other wells have good oil production. So the accuracy of our method here is 100%. The second field of application of TVT technology is brownfield, when conventional methods are used, such as seismic survey, for example. TVT exploration can give additional information that will increase accuracy, focus only on perspective zones, and exclude water areas. Thereby it helps to save money and time. Example number 2. Integration of the results of seismic study with TVT information in Equatorial Guinea. First picture shows us results of seismic exploration. And second picture is TVT image, with main lines of the structure overlaid from the seismic image. We can see strong correlation between these two, and what's more important, TVT technology helps to exclude water areas and build deposit boundaries more accurately. This is Ramashkinskaya oil field, Yuzhno-Ulyanovskaya structure, Russia. One of the biggest deposit, 3 billion tons of oil are already produced here, and it's still ongoing, and the company expects to produce 1 more billion tons. We were asked to make an assessment of this area, which is shown by red line. This is the map of this area. Blue line shows seismic data deposit contour. We made TVT exploration, and as a result we got our contour, which is shown by red color. As you can see, our contour is 35% less than the seismic one. We increased accuracy of boundaries of deposit, and according to our recommendations, company started drilling in this square. All the wells that were drilled in this square have good oil production. So the TVT technology allows to avoid unnecessary wildcat drilling, which brings us to saving money on this stage. The third field of application of TVT technology is assessment of existing wells. One of the most common problem, dry well. TVT technology can answer the question why it is dry. We can find the reasons of this problem and give recommendations on solving this problem and improving oil and gas production where possible. Example number 4. Assessment of dry well, Spain, Cadiz Bay. This well was drilled according to seismic exploration, but when the company drilled it, they got zero oil production. Our team built TVT image of block and fold structures and overlaid it onto seismic data image. Integration with TVT technology clearly demonstrates the reason of zero oil production. There is no collector here. This well was drilled exactly in a dense rock, which is shown by red color. There simply cannot be oil, although the seismic data showed reflection of the structure. With the use of TVT technology, we can avoid dry wells. One more common problem case in oil and gas industry is low or declining oil production. TVT technology can be used to find the reasons and solve this problem where possible. Example number 5. Assessment of a pilot well location, Equatorial Guinea. This is a TVT horizontal section of block and fold structure. F5 well has very low oil production. We were invited to make an assessment of this well, and we built our TVT images, and one of these images is vertical profile of block and fold structure under the well. We can clearly see the oil trap here, but this well was drilled on the edge of this structure. So our recommendation is relocation of this well 1.5 km left. It would significantly improve its production and solve this problem. Example number 6. Scientific works in Vietnam, Dragon and White Tiger deposits. Our team made an exploration and built various TVT images to see the conditions for hydrocarbon formation in this area. And on this picture, block and fold structure vertical profile, we can see that these deposits are located in the transitional zones between dense rock, red color, and the compaction zones, blue color. This is the reason why the deposits are exactly in these spots. And we also built 2.5D map to see the geometry of the area. The fourth field of application of TVT technology, and we call it missed opportunities. Let's go straight to the example. Assessment of offshore prospect structure, Equatorial Guinea. Our team made quick survey and found this area, and we believe that this area is prospective. This seismic data map was provided by client, and we cannot say much about this area according to this image. We defined the depth and build TVT horizontal sections, and every image shows this area as a prospective area. We built local thermal field map of block and fold structure, map of homogeneity, and finally, we built a 2.5D maps to see the geometry of this deposit. And using additional information such as porosity and fluid saturation, we made an estimation. And as you can see, 90 million barrels of oil were simply missed. TVT technology can increase profit by finding and showing these hidden places. And now to summarize, TVT technology can be used in prospecting of oil and gas deposits onshore and offshore as well, including green fields, brown fields, assessment of existing wells, and detecting so-called missed opportunity zones. Let us go through TVT process again. The first step, and the only one the client needs to participate, is providing us with GPS coordinates of license block. Then we get infrared images and other data required, including terrain maps and bathymetry information. We built a 3D model of thermal field, which we use for building different types of horizontal sections and vertical profiles. Then our scientific team makes interpretation of data, and finally we make a presentation of our results and give our recommendations. As a final result and final data, we provide the client with 3D model of oil and gas deposits and other minerals, comprehensive hydrocarbon migration pattern and report, approximate estimation of reserves in block, exact GPS coordinates for recommended drilling point, vertical and horizontal profiles and sections of geological environment at a given depth, maps of spectral indicators of environment landscape systems. After that, our team make an 8-hour seminar for clients specialists. It is called Reading and Interpretation of TVT Materials. So clients specialists will be able to read our material properly. Thermovision tomography is innovative independent technology which is developed to solve main current problems in prospecting minerals, to solve it more accurately than ever before, at the same time reducing execution period and saving money. Thank you for your attention.